Welcome back, welding enthusiasts, to Trades and Tech, your weekly deep dive into the techniques, tools, and trends shaping the metal fabrication world. I'm your host, Tyler Tradesworth, and joining me in the studio today is the always insightful Tori Tradesworth.
Thanks, Tyler. Great to be back and talking shop with our listeners.
Today, we're pulling back the curtain on a welding process that you might not hear about as much in entry-level discussions, but one that is absolutely fundamental to heavy industry and outdoor construction: Flux-Cored Arc Welding, or as it's commonly known, FCAW.
That's right. While MIG welding, or GMAW, is fantastic for many applications, especially indoors on cleaner materials, FCAW is the process that really earns its keep out in the elements and on thick, demanding joints. It's a true workhorse.
And that's exactly our focus for this episode: why FCAW is the go-to choice for so many outdoor, industrial, and structural welding jobs. We're going to break down what makes it different, where you'll find welders using it, and some practical tips for working with it.
Sounds like a plan. It's a crucial process that every serious welder should understand.
All right, let's start with the fundamentals. Tori, can you give us the lowdown on what flux-cored arc welding is and the main variations we see?
Absolutely, Tyler. At its heart, FCAW is an arc welding process that uses a continuously fed tubular electrode wire. The key difference from something like MIG is that this wire has a core filled with flux. Now, this flux does a lot of the heavy lifting. It contains deoxidizers, denatriders, and other compounds that help clean the weld and, importantly, can produce a shielding gas and form a protective slag layer over the molten weld pool. There are two primary types based on how that shielding is handled. First, you have self-shielded FCAW, often abbreviated as FCAW-S. With FCAW-S, the shielding gas is generated entirely from the decomposition of the flux within the wire when it hits the arc. You don't need an external gas supply.
So, the wire itself provides the protection.
Exactly. The second type is dual-shielded FCAW, or FCAW-G. This process uses the flux-core for things like fluxing agents and deoxidizers, but it also requires an external shielding gas, typically a mix of argon and CO2, similar to what you'd use for MIG welding on steel.
The best of both worlds in a way, combining the flux benefits with gas shielding.
That's a good way to think about it. The choice between self-shielded and dual-shielded depends heavily on the specific application, materials, and environmental conditions.
And those environmental conditions are precisely why FCAW, especially FCAW-S, is so prevalent in outdoor and industrial settings. Tori, why is this process so much more forgiving in wind or on less than perfect surfaces compared to, say, MIG welding?
This is where FCAW really earns its reputation as a field workhorse. The shielding generated by the flux, particularly in self-shielded wires, is much more robust and less easily dispersed by wind than the external gas used in MIG welding. Imagine trying to maintain a stable gas shield on a windy day at the top of a new high-rise or on a bridge deck over a river. It's incredibly difficult with MIG. The wind just blows the gas away, leaving your weld vulnerable to atmospheric contamination, primarily oxygen and nitrogen, which leads to porosity and a weak, brittle weld.
Data from welding consumable manufacturers and industry testing consistently shows that self-shielded FCAW can tolerate wind speeds significantly higher than processes relying solely on external gas shielding. While recommended limits vary by wire and application, it's generally accepted that FCAW-S can handle drafts up to 25 miles per hour or even higher before significant issues arise. whereas MIG welding is often limited to wind speeds below 5 to 8 miles per hour without wind breaks. That's a massive difference when you're working outdoors. 25 miles an hour is a pretty stiff breeze. That capability alone makes it indispensable for many jobs.
It absolutely does. And the Flux-Core also helps to clean the base metal as you weld. It can handle moderate amounts of rust, mill scale, paint, or dirt that would cause major problems with MIG welding, which requires a much cleaner surface. Again, best practice is always to clean your joint, but FCAW is more forgiving when conditions aren't perfect.
Which, let's be honest, is often the case on real-world job sites. Beyond the environmental tolerance, FCAW also brings some significant performance advantages, especially when you compare it to MIG welding on thicker materials. Let's talk about speed, penetration, and portability.
These are key factors that contribute to FCAW's popularity in heavy fabrication. For speed, FCAW generally boasts higher deposition rates than MIG welding. This means you can lay down more weld metal in a shorter amount of time.
Industry benchmarks and welding procedure specifications often indicate that FCAW can achieve deposition rates that are 20% to 50% higher than traditional MIG welding, particularly in out-of-position welding like vertical up or overhead. This translates directly to increased productivity and reduced labor costs on large-scale projects.
Higher deposition rates are a big deal when you have miles of weld seams to complete, like on a pipeline or a ship hull.
Absolutely. Time is money in those situations.
Precisely. FCAW also provides excellent penetration. The arc is powerful and digging, which helps fuse deeply into the base metal, creating strong, reliable joints, especially important for thicker plates used in structural applications. You get good fusion at the root and side walls. And on the portability front, particularly with self-shielded FCAW, the lack of an external gas cylinder makes your welding rig much more mobile. You can easily move the machine and wire feeder around a large construction site, climb structures, or access confined spaces without worrying about manhandling a bulky gas bottle.
That portability makes FCAW-S the go-to for field repairs on heavy equipment or structures where bringing a gas cylinder isn't practical.
Exactly. It offers a level.
Explore the full conversation at tradestechpodcast.com, where 101+ years of skilled trades expertise meets cutting-edge tech insights. Thanks for joining us on the Trades Tech Podcast. Until next time, keep building, keep innovating, and let's close the skills gap together.